Hi there. We looked today in class at limits at infinity, and limits at infinity are what we use to find horizontal asymptotes. And when we are finding our horizontal asymptotes, or we're finding what happens as x approaches infinity or x approaches negative infinity, we're looking at our highest power. Okay? And so I've selected 3 different problems, one of which, this number 16, actually has 3 parts. That way I can explain a couple of different thought processes that you want to make sure you're aware of. Okay, so the first thought process we want to look at here are the 3 different scenarios that we might find ourselves in, right, depending on where our highest power or powers are located. Okay, and so with 16a here, we're finding the limit as x approaches infinity of 3 minus 2x over 3x cubed minus 1. Okay, our highest power in this function is this x cubed, and here's why we only care about the x cubed. I'm looking at a number, a huge, massive number, right? X is approaching infinity. So we're thinking here bigger than 698,243,697,212,987, right? Bigger than that, and that's already a huge number, right? And so we're looking at huge, massive numbers, and we are, with this 3x cubed, cubing that number. That huge, massive number, we're timesing it by itself, and then by itself again, and then timesing it by 3, right? I mean, so this is a monster number. Compared to that huge monster number, -1 stops mattering, right? It's minuscule in comparison. The part of this function that's going to be controlling the journey of my graph is going to be the 3x cubed, because he's the dominant, right? It's a principle of dominance. He's the dominant power. He's the one who's going to be saying what the function is doing, right? And so we're only going to be concerned with this 3x cubed because the -1, it's like an ant going up against an elephant. It stops really mattering, right? And similarly, the 3 and the -2x, I mean, they aren't going to matter compared to huge monster number cubed times 3, right? He's going to rule. He's going to dominate. Okay, so here's how we solve this problem. Now that we know we're only looking at our highest powers, we're going to be evaluating our numerator and denominator, comparing those highest powers. And in this case, in my numerator, I have 0 x cubes. Right? I have a 3 and a 2x, but I have 0 x cubes compared to 3x cubes. Right? So let me go ahead and write that really quickly just so we can see what we're talking about here. We have 0 x cubes compared to 3x cubes. And so again, we only care about that highest power. And so then when I plug in the x cubed and the x cubed, they're going to essentially kind of cancel each other out, right? At those big, massive numbers being cubed, they're going to simplify. And we're going to be left with 0 over 3. And so my horizontal asymptote here is going to be 0 divided by 3, which is 0. Okay, and that rule is always going to apply. When your highest value, your highest power is in the denominator, your horizontal asymptote is going to be 0. Okay, let's take a look at another one here. Okay, so we have the limit as x approaches infinity of 3 minus 2x over 3x minus 1. Okay, and so in my highest power in this case is going to be the 1 power, or the x, right? X to the 1, so the 1 power. And in this case, both our numerator and our denominator have that power. Okay, so there's no 0 to kind of take into consideration with this particular problem, not like there was up here, the 0x cubed. There's no 0 here. We've already got our highest powers both in the numerator and the denominator. And so when I compare those, the x's, right, out at infinity, they'll simplify. And -2 divided by 3 is -2 thirds. And so that's my horizontal asymptote. Okay, and then the third scenario, so you have where your highest power is in the denominator, that'll be 0. You have when your highest power is both in the numerator and the denominator, and then they'll simplify. I should say the coefficients will simplify. And then in C, we have the limit as x approaches infinity of 3 minus 2x squared over 3x minus 1. Okay, and so for this one, our highest power is located in that numerator, right? We have an x squared up here. Right? But when we're looking at our denominator, there's no x squared down there. There's actually a, if you want to think of it this way, a 0x squared. And so I'm going to go ahead and take a moment and write that. Minus 2x squared, we have a 0x squared in the denominator. And so our highest powers are here. Okay, well when that happens, we're going to evaluate the x squareds then are going to go ahead and cancel each other out if you want to think of it that way. And then you have negative 2 over 0, which means either, depending on the type of question, you have no horizontal asymptote, because negative 2 divided by 0 is undefined, or it's either infinity or negative infinity, and in this case it would be negative infinity. Or like I said, no horizontal asymptote. Okay? Okay, so I've picked 2 more problems just to kind of continue to walk through these steps here. Numbers 20 and 26. Plus with 26, I want to take a look at kind of one thought process when it's a negative infinity. You do want to make sure you're evaluating the negative as well. Right, and so number 20 here, looking at this, we have the 3x cubed plus 2 over 9x cubed minus 2x squared plus 7. Our highest power is the cubed. Right? X cubes are going to cancel each other out, essentially, and we have 3 over 9, which is the same thing as 1 over 3. Okay? And so then, last but not least, we have number 26, which is the limit as x approaches negative infinity. Now, negative infinity, the rules are still going to apply as far as like if you have the highest power in the denominator, then it's going to be 0, highest power in the numerator, then it's no horizontal asymptote, or infinity or negative infinity. Highest power in both, you reduce the fraction, right? So those rules are still going to apply, but we do want to make sure we're looking at the negative every time, the negative part of the negative infinity. Sometimes that results in a change of sign, okay? And so taking a look here at this one, we have our x over our root x squared, right? And root x squared is x. So these are our highest powers. They match. Root x squared is the same thing as x. Okay. And so then our coefficient is 1 and 1. So coefficient is going to be 1. Now we do need to look though, is it 1 or negative 1? Because as soon as you throw that negative infinity in, it might change sign. Okay, so I'm going to take the negative, and I really only care about the negative. I'm not actually going to be plugging a number like negative 12. I'm going to be just plugging in a negative and seeing what happens. And I'm going to plug that negative into the highest power of my numerator, my denominator. So the negative plugged into the numerator, I'll have a negative divided by the negative plugged into the denominator is a positive. Negative divided by a positive is a negative, and so this is in fact negative 1. And so that's the, I'd say kind of the trickiest part of these problems is making sure that you watch that negative. Okay. At this point with horizontal asymptotes, normal limit rules still apply. You're concerned only with the highest power when you're evaluating your horizontal asymptote, principle of dominance. Okay, and there you go.